Alright, welcome to the video lesson for week 3. So before we get into the actual content for week 3, I just wanted to talk to you about what you're going to be expecting for the week. So the first thing that I need you to do is to finish watching the video. So I noticed for the first week that I posted a video, I had about 43 views, which is what I sort of expected between the two classes. Now I've thought that maybe there might be a few people that might not watch it, just because that's how it goes sometimes. But for this last week, there was only 15 views. So 15 views of the lesson out of 2 classes. It kind of makes me wonder whether or not it's worth my trouble to actually produce these videos. Even though I think that on my side it's an effort to make it more personalized rather than just posting a random video. So please make an effort to share the video with your classmates and watch it, and it'll probably help you to understand the material a little bit better. Number 2, so we have questions 1 to 6 on page 282, so that's for 7.5, and then questions 1 to 5, 7D, 7E, and 7F on pages 287. Then there's going to be the homework book questions just like we did last week and the week before that, and then there'll be the Google Forms to go along with that. I'm also going to be sending out some supplementary videos, so make sure you check those out. There's going to be a Brain Pop, which is sort of like an online quiz game type thing. We have a username for that. That's grade 7 FFCA, and the password is grade 7. I'll also be posting that to Edsby in the Google Classroom stream. That way you can just sort of copy and paste it. And then at the end, there is going to be a Chapter 7 Google Form test. So that's going to be all of Chapter 7, and that's going to be, testing you on all the skills and knowledge of Chapter 7. One thing I want to sort of stress is please attend the Google Meet video chats. So those are really important for you to be able to, first off, ask questions if you need to. Second off, it's good to be around when other people ask questions, because sometimes it'll help to improve your understanding. And I think it's just really important to make sure that you're interacting with your peers. So during this time, I know that we're all kind of cooped up indoors, and by having some kind of social interaction, even if it's through a video chat, it's a healthy thing to do. And I know for myself that initially I don't really enjoy getting the chat going, but once it's sort of up and running, I'm really happy and glad to see other people's faces and hear their thoughts on things. And then whenever the video chat's done, I'm always so glad that I took the time to speak to other people. So please make sure that you're staying connected. And also there might be little things that you forget. So looking at your guys' submissions of all your work, there are some students who have handed in everything, and chances are that has a lot to do with who's attending the video chats, and there's other people who are missing a lot, and that might be because they're not as invested and they're not participating in the video chats. So please make an effort to attend those. Well, it looks like it's on to probability. What are the chances of that? Probability is defined as the numerical description of how likely an event is to occur. So this is expressed as the number of outcomes that are favorable to that event over the number of possible outcomes. So for example, if you're rolling a die and the chances or probability of getting a 6. So this would be expressed in one of 3 ways. So we have our fraction form, so that would be 1 over 6. So we have a 1 in 6 chances that when we roll our die that it's actually going to end up being the number 6. That can also be expressed as a ratio. So that's how that would be expressed. And then we could also represent it as a percentage. So this would be 16.7%. Now, we've already gone through this year, but to convert a fraction into a percentage, you would just take 1 divided by 6. That's going to give me 0.16 repeating. Then I'm going to times that decimal by 100, and that gives me my 16.7. And then just a couple other terms here. So an impossible event, so that would be something that has a 0% chance. So if I have a 6-sided die, what's the probability of me rolling an 8? Well, that's impossible because my die only has 6 sides, so that would be considered an impossible event. And then a certain event would be that there's a 100% chance that it's going to happen. So for example, if there was a question like, what are the chances of getting a heads or a tails, and you flip a coin, well, it's going to be a certain event. It's going to be 100% chance because it's going to either land as a heads or a tails. Okay, starting off with a really easy example, just to kind of get used to this. So on a 6-sided die, what are the chances of rolling a 3 or a 4? Well, we know that our die has 6 sides, so it's going to be out of 6. And we have 2 options. Our 2 options are 3 or 4, so that's going to be 2 over 6. But I can reduce this. Obviously, this is going to be 1 over 3. And then if I was going to express this as a ratio, it'd just be 1 and my colon 3. And then for a percentage, I would take 2 divided by 6. That's going to be 0.333 repeating. And then I take my 0.33 times that by 100, which is going to equal 33%. So it would just be a really easy question. All right, so to look at another similar question, but sort of presented in a different way. So on a 6-sided die, what are the chances of not rolling a 5 or a 2? So this might come into play if you're playing a specific type of board game. So if we have a 6-sided die and we're interested in the probability of rolling things that are not 5 or a 2, well, that means that there's 4 other options because we have our total of 6, and we're just interested in those 4 other things. So we'd have that as 4 over 6 as our fraction. So if you're going to roll the die, there's a 4 out of 6 chance that you're going to end up with a number that is not 5 or 2. We can't reduce this, but we can also represent it as a ratio. So it'd be like 4 to 6. And then as our percentage, we're going to take 4 divided by 6. That's going to equal 0.6 repeating. And then we're going to multiply, 0.66 repeating. And then times that by 100. That's going to give us 66%. So if you're going to roll a die, the chances of getting a number that are not 5 and 2, well, there's a 66% chance that that is going to happen. So the next thing we're going to look at are called independent events. So it's the result of one event that does not depend on the result of the other event. So for our example here, we have a coin toss. So if we have 2 coins and we flip one coin, the flipping of that first coin does not impact the probability of the next coin. So the first coin obviously is 50-50, it's either going to be heads or tails. And when I go to flip the second coin, just because I flip this coin doesn't change the probability of this coin. Now this is different from a dependent event. So for example, maybe there's some kind of a lottery, maybe there's 3 people involved and there's 2 prizes. And the first person wins a prize, and they're only allowed to win one thing, and once they win that thing, they're eliminated. So the probability of the first thing that occurred, it'd be a 1 in 3 chance. So then once that person's removed, then it would be a 50-50 chance, a 1 over 2 chance for the next draw of the prize. And that's an example of a dependent event. So there's 2 ways that we can express these events that take place. One is through a sample space. So I have my first coin and my second coin, and it's basically just like a bit of a chart. So I have the 2 possibilities, heads or tails. And then on the side here, I have heads or tails. And then inside of the boxes, I just have the combination of the 2 where they would intersect. So I have heads, 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 heads. So heads, tails, tails, heads. So tails, heads, and then tails, 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 tails. Or another way to express this is with what's called the tree diagram. So if I have my coin here, so I have either it's going to be heads or tails. And then after that first event has occurred, the second coin would either be heads, tails, heads, or tails. And then I could write all of the possible outcomes in a column over here, which is very, very similar to what we have in our sample space. So that's the difference between the sample space and a tree diagram. One last thing is if we had a question related to our coin toss. So let's say, for example, the question was, what is the probability of getting tails with 2 coins? I could look at my sample space really quickly and just look, okay, well, I have that occurs 1 out of 4 times, so that's 1/4, or as a ratio 1 to 4, and then as a percentage that would be 25% chance. All right, so I'm going to ask you a little bit more of an advanced question. So this is a hypothetical situation. Obviously, if you are going to purchase a car, I think that there's dealerships that have cars that they stock more frequently because they know that customers prefer certain options. So it's not like this would be accurate of the true real world situation, but just for fun I figured we would do something a little different. So Tesla Model 3, so that's obviously the electric car manufacturer. They make 3 different sort of different models. So they make a standard range, so that has a smaller battery pack. They have the long range, which is, I believe it's all-wheel drive, and it has a larger battery, which allows it to travel further. And then they have the performance variant, which has the largest battery and the most performance. And then they offer each car in white, black, silver, blue, red. The interiors can either be black or white. And then the last option is either autopilot or full self-drive. So what is the probability of going to a Tesla dealership and there is a performance red one with a white interior with full self-drive? Okay, so I'll give you a couple minutes to figure that out. All right, so going back to the original question, what is the probability of me finding a performance version, red paint, white interior with full self-drive? Well, let's look at all the possibilities of just the standard range model. So from standard range, it goes out to 5. We can have a white model, a black model, silver, blue, and red. And then from each one of those, we have a white interior, black interior, black one with a white or black interior, a silver one with a white and black interior, a blue one with a white or black interior, a red one with a white or black interior. And then each one of those can either have autopilot or full self-drive. So in total, we have 20 possibilities just for our standard range. But we know that we have 3 original models. So you could basically replicate this entire tree diagram for not only the standard, but the performance range and the long range version. So if I know that the standard range, there's 20 possibilities, the long range, there's 20 possibilities, and the performance version, there's 20 possibilities, I know that there's a total of 60 different possible variations of the Tesla Model 3 available. So if I was gonna go to the Tesla dealership and hopefully find the Model 3 variant that I was interested in, so the performance version with a red exterior, a white interior, and full self-drive, that would be a 1 in 60th chance, so 1/60 or 1 to 60 ratio. And then if I was to find the percentage, I'd go 1 divided by 60, which equals 0.016 repeating, times that by 100. That's going to give me 1.6%. So the probability of me being able to go there and get the exact vehicle that I want is actually quite small. Now, most dealerships are probably not going to create an equal amount of variants. They're probably going to use some kind of market research or use focus groups where they actually have a group of people and talk about which ones they're more likely to order. And they might actually collect data from their first few months of sales to figure out, okay, what's the mode of the sales? So maybe the black one with the black interior is selling the most frequently, maybe because it's cheaper. I know that right now the models that are black aren't as expensive because the paint is a little bit cheaper to manufacture. So they might actually use different metrics to determine what they're going to sell. But just based on our little experiment here, very low percentage of us, or very low probability of us being able to find the exact car that we want.